Okay, now we will do a demo on static friction. So what you see here is a ramp, and I can change the angle of the ramp by raising this. On this ramp, I place 1 kg mass initially, and when the angle is 0, the weight of the mass and the normal force to the surface, they are balancing each other, mg and n. But now I change the angle of the ramp. So now the gravitational force and the normal force are no longer balancing. There's a component of the gravitational force acting this way, but it cannot move the object because there is some force of static friction. But if I give it enough angle, then the mass begins to move. So that component of the gravitational force can overcome the force of static friction. And if you look at this diagram, which you have also looked at in the lectures, you can see why that happens. So this normal force is acting perpendicular to the surface. At 0 angle, mg and n were balancing each other. But now as I raise the angle, they are no longer aligned in the same, in a line basically. So there is a component of the gravitational force, mg cosine theta, that's balancing the normal force. But there is also a component along the slope, mg sine theta. And this has to overcome the force of static friction, which is initially preventing the motion of the object. And what is the expression for this static frictional force? And it has a form like this, as you have seen, mu s times n. Mu s is the coefficient of static friction that can vary from material to material. It just depends on the surface, how rugged it is. And n is the normal force. So this is the force of static friction. And different objects can have different coefficients of static friction, mu s. For example, let me show another object here. The surface is different compared to this. This surface is smoother than this one, a bit rugged. So this has a larger mu s, the coefficients. And let me now try to raise these two in the ramp. Let's see what happens. See, the 1 kg mass is moving. The other, both are 1 kg masses, but the one with the larger mu s, that is moving later at a larger angle, right? We can try this again. And now let me use another mass. So this has a surface like this that is even more rugged than this. So this has a even higher mu s. And now let me raise these two masses. So one begins to move, the other doesn't. Because mu s is larger. The coefficient of static friction is larger because of the rugged surface. Thank you.